demonstrating. Alright, here we go. So number one here, we are looking at the fact that we've got an altitude there in that right triangle. And if we remember right, the altitude is the geometric mean of the two parts of the hypotenuse that it splits it into. And so that tells us that 12 is being the length of the altitude should go on the top on one side of the proportion and on the bottom on the other. And then the parts of the hypotenuse that it splits it into go in the other spots, so the x and the 8. And so from there, now it's a proportion, so we cross multiply, which is going to give us 144 equals 8x. And solve for x, we're going to divide by the 8. And that's going to give us that 18 is equal to x. Alright, so then number 2, we're still looking at the same kind of problems, except for now we're looking at a leg of the right triangle with an altitude drawn. And the leg of the right triangle is the geometric mean of the part of the hypotenuse that's closest to it, and then the entire hypotenuse. So we have to keep in mind that the whole hypotenuse is going to be 4 plus 9, or 13 there. So the leg is that geometric mean, so that means the x is going to go on the top on one side, bottom on the other. And then we fill in the other two parts with the part of the hypotenuse that's attached to that leg, which is 4, and the whole hypotenuse, which is 13. So then we cross multiply. It's going to give us x squared equals 52. And to solve for x, we take the square root of both sides. And so x is going to equal, we can simplify that down to 2 square roots of 13. Or that would be somewhere about 7.2, something like that if you put it as a decimal. So then number 3 and 4 here, we are just using Pythagorean's theorem. All right, so c squared equals a squared plus b squared. And so remember that c is always the hypotenuse, so our hypotenuse is the x. So we're going to say x squared equals 3 squared plus 4 squared, or x squared equals 9 plus 16, which will become x squared equals 25. So then to solve for x, we take the square root of both sides, and our x value is going to be 5. Then another part of the question is determine whether it's a Pythagorean triple. And remember, a Pythagorean triple means that all 3 sides have a length that is a positive integer, or in other words, a whole number. So 3, 4, and 5 are all whole numbers or positive integers. So then, yes, it is a Pythagorean triple. So then number 4, once again, we're going to use the Pythagorean theorem, but in this case, the x is on one of the legs. So we're going to start out with 41 squared, 41 being the hypotenuse, is going to equal x squared plus 40 squared. And so when we square 41, we get 1681. It's going to equal x squared plus 40 squared is going to be 1600. Move the 1600 over. So 81 equals x squared. And take the square root of both sides to get x. And we should end up with x equals 9. So now if we look at the numbers we've got 9, 41, and 40. All 3 are positive integers or positive whole numbers. And so we can say that this one also is a Pythagorean triple. what we're looking at to determine that it's not a Pythagorean triple would be one of those numbers having a square root in it, or a fraction, or a decimal. Alright, so then 5, 6, and 7. First thing it asks is to determine whether or not those links would create a triangle. And then if it does create a triangle, what kind of triangle is it going to be? An acute, obtuse, or right? So for the first part, we check to see if it's going to be a triangle by adding the two smallest sides together to see if they're greater than the third side. If the two smallest sides added together are not bigger than the third side, then it can't make a triangle. So say 7 plus 4 has to be greater than 7, which in this case you got two sides that are the longest side, so we're just using one of them on the other side of the greater than sign. So 7 plus 4 is 11, which is greater than 7 being the longest side, so it will be a triangle. Now to determine what kind of triangle, we take the longest side. Once again, we got 2 here, so we're just going to take one of the 7s, square it, and then we're going to compare it to the other two sides squared and added together, just like in the Pythagorean theorem, right? C squared equals a squared plus b squared. But in this case, we're leaving out the equal sign because we want to see how they actually compare. So 7 squared is going to be 49. Comparing that with 49 plus 16, or ultimately 49 compared to 65. So in this case, the 49 is less than 65. And so if it's if the c squared is less than a squared plus b squared, that tells us that this is an acute triangle. And the rule being, if c squared is less than a squared plus b squared, it's acute. If c squared is greater than a squared plus b squared, it's obtuse. And if c squared is equal to a squared plus b squared, then it's right. So next triangle, number 6, has sides of 8, 9, and 15. So we add the smallest two together, see if they're greater than the biggest side. So that's 17 is greater than 15, which is true. 17 is greater than 15. So then once we've got that, now we can plug it in to compare it. So 15 is the longest side, so 15 squared compared to 8 squared plus 9 squared, or 225, is compared to 64 plus 81, or we're comparing 225 to 145, which 225 is greater than 145. So since the c squared is greater than a squared plus b squared, it makes this an obtuse triangle. Alright, so then number 7, got sides of 9, 12, and 13. So check to see if it's a triangle. So 9 plus 12, is that greater than 13? 21 is greater than 13, so it does make a triangle. So now we're going to compare 13 squared to 9 squared plus 12 squared. So 13 squared is 169. Comparing that to 81 plus 144, or 169 compared to 225. So 169 is less than 225, so our c squared is less than a squared plus b squared, making it an acute triangle. Alright, so then 8, 9, and 10 all deal with our relationships of special right triangles. And the first one, number 8, is a 45, 45, 90 right triangle. which follows this relationship right here, where the two legs are the exact same length, so both represented as x here, and the hypotenuse is the square root of 2 times the length of a leg, square root of 2x. So when we look at this triangle here, we notice that one of the legs is 9, x is the other leg, so since it's a 45, 45, 90, we know that the two legs have to be the same, so simply recognize that x should be 9. And then y, which is the hypotenuse, should be the square root of 2 times a leg. So y is going to equal the square root of 2 times a leg, or 9, which we rewrite a little neater as 9 square root of 2. So x is 9, y is the 9 square roots of 2. So then number 9, we're looking at a 30, 60, 90 right triangle, which has a different relationship than a 45, 45, 90. 40, 30, 60, 90, everything's compared to the short leg. So if the short leg is x, the hypotenuse is 2 times the short leg, or 2x, and the long leg is the square root of 3 times the short leg, or square root of 3 times x here. So in this case, our short leg is 8, x represents the hypotenuse, and the hypotenuse should be 2 times the short leg, so that's going to be 2 times 8, or 16 for x. And then the y, being the long leg, should be the square root of 3 times the short leg, or square root of 3 times 8. Rewrite it as 8 square roots of 3. And that's all there is to that one. Now number 10 takes it up a notch because we have two 30, 60, 90s attached to each other. They give us the length of the long leg here at the bottom as 8, and we're trying to find the short leg on the top triangle. So the order we got to go is we start with the long leg on the bottom. We got to find the short leg because everything's related to the short leg. So we find the short leg of the bottom triangle. Then we can use it to find the hypotenuse on that triangle, which once we know that value, it becomes the long leg of the top triangle, and we can go from the long leg to the short leg, which is where our answer should be. So starting out with 8, it's the long leg, and the long leg is supposed to be the square root of 3 times the short leg. So I'm just going to call the short leg there y, just to have a label on it. So that length of 8 should be equal to the square root of 3 times the y. And so to solve for y, we're going to divide by the square root of 3. And so that'll give us a fraction of 8 over the square root of 3, which we can't have a radical in the denominator, so we have to rationalize it by multiplying the top and bottom by the square root of 3. So ultimately we end up with y is equal to 8 square roots of 3 over 3. So that's the short leg over here on the bottom triangle. Now we're going to use that to find the hypotenuse, this h right here. And the hypotenuse for a 30, 60, 90 is 2 times the length of the short leg. So this h should be twice the short leg, or 2 times 8 square roots of 3 over 3, which is simply going to be 16 square roots of 3 over 3. So that h there in the center is 16 square roots of 3 over 3. Now we're looking at the top triangle. So that h now is the long leg of the top triangle. And the long leg is the square root of 3 times the short leg. In this case, our short leg is the x, which is where we're trying to get to ultimately. So that long leg, 16 square roots of 3 over 3, should be equal to the square root of 3 times the x value, that short leg. And divide both sides by the square root of 3, which dividing by the square root of 3 is the same thing as multiplying by 1 over the square root of 3, which allows us to cancel out the square roots of 3, since we got one on the top and one on the bottom. So we end up with 16 over 3 is equal to x, which is the answer we're headed for. Alright, so 11, 12, and 13, these are all dealing with sine, cosine, and tangent. And so we remember the functions. Sine is opposite over hypotenuse, cosine is the adjacent side over the hypotenuse, tangent's the opposite side over the adjacent side. So we're finding the sine of A, and from angle A, 5 is the opposite side, 12 is the adjacent side, and 13 is the hypotenuse. So we're looking for the opposite over the hypotenuse, which would be 5 over 12, or 5 over 13, I mean. So 5 over 13, the opposite over the hypotenuse. And so the instructions ask you to give it in 4 decimal places. So we're going to take that 5 over 13, divide it out. That'll be 0.3846. And then the next one is the cosine of A, which is the adjacent side over the hypotenuse, so 12 over 13. So if we divide that out, 12 divided by 13, 0.9231. And lastly, the tangent of A. Tangent is the opposite side over the adjacent side, so from A, 5 is the opposite, 12 is the adjacent. So 5 over 12. Which is going to give us 0.4167. Alright, so then number 12. Angle A is over here. So 6 is the opposite side, 8 is the adjacent side, and 10 is the hypotenuse. So for the sine, it's the opposite over the hypotenuse. Well, that's going to be 6 over 10. Which if we divide that out, that's going to be 0.6000. Since it has to go to the 4 decimal places, go ahead and put in zeros to fill in those 4. Cosine of A is going to be the adjacent side over the hypotenuse. So adjacent is 8, 10 is the hypotenuse. So that's 8 over 10, or 0.8000. And then lastly, the tangent of A is going to be the opposite side over the adjacent side. 6 is the opposite side, 8 is the adjacent, so 6 over 8. And 6 divided by 8 is 0.7500. Alright, so then 13 from angle A, you got 1 is the opposite side, square root of 12 is the adjacent side, and square root of 13 is the hypotenuse. So for the sine of A, opposite over the hypotenuse is going to be 1 over the square root of 13, which if we were leaving this as a fraction, we would have to rationalize that denominator. Right, multiply the top and bottom by the square root of 13 to get it out of the bottom, which will give us the square root of 13 over 13. But really, since we're asked to find it as a decimal, we can just plug 1 divided by the square root of 13 into our calculator and get it into a decimal, which would be 0.2774. Cosine is going to be the adjacent over the hypotenuse, which comes out as the square root of 12 over the square root of 13. Once again, if you're leaving it as a fraction, we'd have to rationalize it by multiplying by the square root of 13 top and bottom. But since we're doing it as a decimal, I'm just going to do the square root of 12 divided by the square root of 13, which will give me 0.9608. And lastly there, the tangent of A is going to be the opposite over the adjacent. So 1 over the square root of 12. And so 1 divided by the square root of 12 will be 0.2887. So there's our sine, cosine, and tangents. Alright, so 14 through 17, we are using our trig ratios to find the missing part. We're solving for x in this case. So this first triangle, number 14, they gave us 30-degree angle. They gave us that the opposite side is 7, and our x is on the hypotenuse. So opposite and hypotenuse should start coming clear as sine to you when you look at that. And so what we know is the sine of 30 degrees based on this triangle should be equal to the opposite side, which is 7, over the hypotenuse, which is x. And then once we get it set up like this, then we want to solve for the x, which is in the denominator. So first thing we got to do is multiply both sides by the x to get it out of the denominator. So now we have x times the sine of 30 degrees equals 7. And to get x by itself, we've got to move that sine of 30 over to the other side. So divide both sides by the sine of 30 degrees. And so x is going to equal whatever 7 divided by the sine of 30 is. Which 7 divided by the sine of 30 is 14. So that's our x value. Alright, so then 15, we got a 52-degree angle here. X is on the adjacent side to that angle, and 14 is the hypotenuse. So we're trying to find the adjacent. We got the hypotenuse, so adjacent over the hypotenuse is cosine. So we're going to use the cosine function here. Say cosine of 52 degrees should be equal to the adjacent side, which is x, over the hypotenuse, which is 14. So multiply both sides by 14. So 14 times the cosine of 52 degrees equals x, and 14 times the cosine of 52 is 8.6 equals our x. Alright, so then the next ones we're solving for the angle. So you got the opposite and the hypotenuse from the x. So that tells us that opposite and hypotenuse is sine. Alright, so 16, here we're solving for the angle instead of a side. And so we've got x is the angle, and from that angle we've got an opposite side of 12 and a hypotenuse of 24. So opposite and hypotenuse should lead us to think of sine. And so the sine of that angle x should be equal to the opposite over hypotenuse, or 12 over 24, which will be 1/2. And so since the sine of the angle is 1/2, to find the actual angle we use the inverse sine. So sine -1 of 1/2. So we're doing second function sine button on your calculator of 1/2. And when we do that, we should get 30 degrees. Remembering when you're dealing with these trig functions and angles that we've got our calculators in degrees, so we got the right values. And then 17, we've got angle x, and we're given the opposite side, which is 27, and the adjacent side, which is 38. So opposite and adjacent should have us thinking of tangent. So here we're going to say the tangent of angle x is equal to the opposite side, which is 27, over the adjacent side, which is 38. And so if the tangent of x is 27 over 38, then to find the angle, we're going to use the inverse tangent of 27/38. So inverse tangent of 27 over 38 is going to give us 35.4 degrees. So that concludes the review.